In this video, we're going to learn how to create a pie chart visualization as part of an HTDAP program. We will start with the beginning of a program that we designed in previous videos. I'll keep the planning steps and make systematic changes to these steps where necessary so that our program can create a pie chart. A pie chart is a circular graph that is divided into slices to show proportions of the whole. For this example, we'll plot proportions of BC's population for a given year, and we'll consider the proportion of the population that has grown due to births, the proportion that has grown due to migration, and the proportion that was already part of BC's population the year before. Step 1A does not change, as our file still contains the same information. Step 1B needs to be updated, as we need to add our pie chart as a possible program output and choose it as our goal. So our goal for our program will be to create a pie chart that shows the proportion of BC's population in a given year that is growth due to births, growth due to migration, or pre-existing. This is no longer a question that our program is trying to answer, but it is still the goal for our program. In step 1C, I need to update my example. Previously, when our programs produced a non-visual answer, we could write our example in the form of an expect, which was sufficient to show what type and form of answer we expected our program to output. When our program will create a visualization, like our pie chart, we want to write an expect and draw an example of what our program will produce. I like to hand draw the examples, although you could use a drawing program on your computer if you prefer. Once you've hand drawn the example, you can take a picture of it and then insert the image into your markdown cell using the Edit, Insert Image menu option. The purpose of the example is to think about what we want the chart to look like. We are not trying to draw the exact output. In other words, you should not worry about finding the exact data and drawing it. Instead, focus on what each piece of the pie chart will represent and what a rough shape of an output chart might be. The data definitions that we built in the previous example do not include births and migration, so we need to update them. As a quick reminder of what we're starting with, we have a compound to store a year's population change and a list of these population changes. We need to update the population change compound to include births and migration, and we'll work systematically through the steps of the How to Design Data Definitions recipe to make these changes. First, we'll change the data type definition to include births and migration, their types, and their ranges. Births is an integer. Migration is also an integer. We're going to move this range back to total population. That's where it was. It just got moved when I was editing. Births is also a non-negative integer. However, migration could be positive or negative. There could be a net increase, a positive migration of people moving into BC, or there could be a net decrease, a negative migration of people moving out of BC. So we do not need a range for migration. Next, we need to update the interpretation to include births and migration. To update the examples, I have looked at the information in the CSV file and have updated examples to copy and paste in. Finally, we need to update the template. Nothing needs to change in our list type. Since we updated our data definitions, our read function for step 2b also needs a slight update. We now need to read in the births from column 5, the total migration from column 3, and parse them both as integers before we create our new population change data point. I'm going to put each of these on its own line, otherwise the one line of code would end up too long and overflow the cell, which is difficult to read. So now I'll run these tests for read and I expect them to pass.